alpha beta unsaturated additions. Okay, alpha beta unsaturated additions. So generally they called as Michael additions. Okay. So before that, let me discuss about the workouts. So these are the last class workouts which are based on the Grignard reagent. So once phenyl magnesium bromide is react. Okay. Okay, just a minute. Am I audible now? Yeah. So here I am discussing the previous workouts, okay, that's given in the last class, which are based on Grignard reagent. So in the Grignard reagent, the alkyl group acts as a nucleophile, which will be going to attack on the carbonyl carbon, resulting into the OMGX. Okay, so Grignard based anion, okay, oxide ion, which will be going to support the H plus by the hydrolysis. Okay, so it is resulting into the alcohol. Okay. Similarly, if it is ethyl, it's going to attack. So ethyl will be going to add up to the carbonyl carbon. So, this will be the product. Okay. So both will give similar kind of product. Okay. So these two are going to give uh, same product. So you can synthesize this product from the either of the compounds. Okay. So if it is formaldehyde, it's going to give primary alcohol. So this is going to attack. This one CH2 OH. Okay. So these are the products. So cross check with your answers. If it is correct, make it correct. Okay. If it is wrong, try to think what was the mistake that you have done in your workouts. Okay. So if this is the case, and whatever the earlier dicyclohexyl group is there, okay, similar kind you can make. Okay. So ethyl is attacking. So remove the ethyl. Okay, and make it carbonyl. So that will be the starting material. So this is what the starting material. Okay. So here whatever the groups already present, that we don't require. Okay, so what is added to the product, that will be our Grignard reagent. So this isobutyl group is there, isobutyl group is there, and methyl group is there, so methyl group is there. So the next added will be isopropyl. So you need to take the isopropyl magnesium bromide or magnesium chloride. Okay, so that will be the Grignard. So questions may be in different kinds. Okay. So based on the questions, you need to see whether they are asking for the products or whether they are asking for the starting materials. Okay. So that you need to see. Okay. So somebody trying to join. Let's see. Try once again. Okay. So next, if it is excess, so if it is excess, ester will be going to convert into tertiary alcohol. So first it is going to attack, so resulting into the ketone. So this will be the ketone, and further one mole molecule will be going to attack here. So resulting into this becomes O minus. So on hydrolysis it becomes alcohol. Okay. So this is also similar kind product which is already derived from the question number 1 and 2. Okay. So single product can be made from different compounds. Okay. So that is what the Grignard reagent specialty. You can use multiple dimensions of the Grignard. Okay. So whatever the Grignard, the product will be based on that fragment. Okay. So next, RMGX. So if this is the question where alcohol is there, okay, Grignard will be going to form alkane instead of Grignard product or nucleophilic addition product. Okay, so it's going to become aldehyde and OMGX, and this will be RH. Okay. If it is OMGX treated with water, it's going to give again this one. Okay, alcohol. So, but the product will not be other than the alkane. Okay, so alkane must be formed. Okay, so be careful with the acidic group. If it is acidic proton is there, that's going to add it up with the proton. Okay, Grignard nucleophile will be acting as a base, so it will obstruct the proton. Okay, so next. Okay, so next it is lithium reagent. So this, if it is treated with lithium compound, which is also organometallic compound. So it acts as a nucleophile. This is a secondary butyl lithium. Okay. So here lithium is attached. Okay. So this acts as a nucleophile. It will be going to attack O minus and Li plus, and here hydrogen was there, and what we use the secondary butyl group will be this. Okay. So once it is hydrolyzed, this is replaced with the hydrogen. Okay, this could be the product. Okay. So these are the workouts. So if you are trying to do the workouts, it is able to easy to solve, and you able to think about it. Otherwise, it will be difficult. And whatever the number of times you've been watching at the videos, it's not useful. Okay. So next, the yesterday's workout. Okay. So products for the chain reaction. Okay. So if I give sooty flame and non-aromatic compound, okay, that will be only one compound. Or if it is giving sooty flame means there is a carbon and hydrogen ratio 1:1. Okay. So generally aromatic compounds, for example benzene C6H6, they will give sooty flame. Okay. So non-aromatic compound which is going to give sooty flame is acetylene, which is C2H2. Okay. So this is acetylene. So not just based on the sooty flame, you can also make it confirm by the product of this. Okay. So it is given acetaldehyde. Okay, which are here if it is addition reaction, HCl addition, HCl addition, 2 moles of HCl addition. Okay, and after that nearby treatment it is given acetaldehyde. So it is indicating that there was 2 chlorines and a carbon. Okay, so this is what the C. Okay, which on hydrolysis with NaOH or the nucleophilic substitution reaction, these two become OH and OH. So presence of two hydroxy groups on one carbon is unstable, resulting into the dehydration to give acetaldehyde. Okay. So before that it is HCl addition. So there must be a double bond. Okay. So this could be the starting material of this. So this is B. If it is A, so this. Okay. So in the either of sides with this reference and with this reference, it is matching. So it is this. Okay. So when vinyl chloride is treated with magnesium, so it is going to give vinyl magnesium chloride Grignard reagent. Okay. So it is going to attack on the cyclohexanol. Okay. So that is what resulting into the vinyl added. Okay, vinyl addition cyclohexanol. Okay, so this on HBr treatment, so here olefin is there, again it is going to give bromination at this position as a major. Okay, bromination at less substituted position as a minor product based on the Marconi rule. Okay. So this on treatment with magnesium, it is again going to give Grignard reagent. Okay, magnesium bromide. This on treatment with NaOH, Br will be going to replace with the nucleophilic substitution reaction. Okay, that we will also see. Okay, so this is the product. Okay, so whoever done the products, then they can cross check. Okay, so if anyone not tried, try to search the reactions. Okay, so that it will make you remember easily. Okay, so to remember perfectly and to solve the question accurately, you need to see the reactions multiple times. But looking at the same question many times, you are going to feel that this is a very known question, so you are able to solve. So, but the thing is, mind will not memorize by looking at it for long time. So, by practicing it, your mind will observe more concepts and more reactions. Okay. So, try to solve as much as questions that are possible. Okay. So, next, so this is the second question. So HCl addition, so it can give major and minor. So this is major. Okay. Which are treatment with magnesium in dry ether, it is going to give Grignard, magnesium chloride. Okay. So magnesium chloride on attacking with ester, it's going to give ketone. So I expecting you have done this. So I am just revealing the answers. Okay. If you have not at all tried, you just need to practice again. Then you need to watch this video again. Okay. So if it is ethyl magnesium bromide, it's going to attack on the ketone, so resulting into the alcohol, tertiary alcohol. So this is the product, which is E. Okay. So if at all this Grignard reagent attacked on this, so this is also going to give same because both are acid derivatives. Okay. Resulting the leaving group elimination and the replacing of the Grignard reagent. So this is also going to give this. So this untreated with again 1 more mole of Grignard reagent. So what is C? C is the compound of this. Okay. So which on again treatment with Grignard is going to attack. So resulting into the this is water and this is alcohol. Okay. So D will be this. Okay. Next. So X is given, which is resulting into the ester. So by the elimination of water, so it must be a gamma hydroxy acid. So acid and alcohol and dehydration will be resulting ester. Okay, if it is cyclic ester or lactone, it must be treated with cyclic acid and terminal alcohol. Okay, this we already discussed in the nomenclature of lactones. Okay, so lactone synthesis also we have seen. Okay, once the lactone is formed, it will be treated, it is treated with 2 moles of ethyl magnesium bromide, so resulting into what? Alcohol. Okay, so 1 mole is going to left, double bond C2H5 and this become OH, and another mole on the carbonyl carbon is one ethyl, this is another ethyl, this is alcohol, and this is another alcohol. Okay. So here you are having two alcohols which can be dehydrated by using concentrated H2SO4. So as a water elimination, it's going to give 1, 2, 3, 4, 5, 6, 7 member ring. Okay. So on the oxygen attached carbon, there are two ethyl groups. One, two. Okay. So this will be the product. Next, cyclohexanone is given and treated with molecule resulting into the allyl group addition. So it will be allyl magnesium bromide or allyl lithium compound. Okay. So here I am taking allyl magnesium bromide. This on addition is going to give bromine at more substituted carbon with marconic oxide. Okay. So this on treatment with Grignard is going to give Grignard reagent. Okay. So once Grignard is found, it's going to attack on the carbonate, resulting into the so this is the product. Whatever may be the groups, whatever may be the size, whatever may be the number of substitutions. Once you follow the reaction types as strategy, it is easy to write any reaction. Okay. So make learn of things or specific reaction types so that you can adapt it to the different reactions and different substrates so that you can solve any type of reaction based questions. Okay. So this is about the workouts. So today we are going to see the one of the important. So it is repeatedly asked in the name reaction, okay, as well as the nucleophilic substitution reactions based, okay. So that is Michael addition. Okay. Michael addition. So Michael addition is what about is it is about the alpha beta unsaturated carbonyl compound. Okay, alpha beta unsaturated carbonyl compound. So what is alpha beta unsaturated carbonyl compound? Carbonyl compound, the carbon which is attached to the carbonyl, this is carbonyl. Okay, carbon which is attached to the carbonyl is considered to be alpha. Okay, the next carbon will be considered to be beta. Okay, so unsaturation means double bond. Okay, so if any group which is with double bond at alpha beta and it is with carbonyl, they are said to be alpha beta unsaturated carbonyl compound. Okay, so if it is alpha beta unsaturated carbonyl compound, okay, so this double bond can act as a nucleophile. Okay, this double bond can act as a nucleophile and this carbonyl can act as a electrophile. Okay, so there are two possibilities. One can act as a nucleophile, one can act as a electrophile. Okay, within the compound system. Okay, so generally if it is Michael addition, when it is treated with nucleophile. Okay, when it is treated with a nucleophile, if it is directly attacking or if it is strong nucleophile is going to attack here. Okay, so that carbonyl gets shifted onto the O minus. Okay, so the electron density will be going to low. Okay, and there is another possibility if this alpha beta carbonyl compound trying to conjugate. This is also possible. So there is another electrophilic part or electrophilic point at this point. Okay. So which is what beta carbon. Beta carbocation may be generated that may be attacked with the nucleophile. Okay. So when it is weak nucleophile, this conjugation can happen and it's going to attack. Okay. So that is the possibility. So with these two possibilities, we going to see the different kinds of examples. So which are can be 1-2 addition, 1-2 means this one, 1-2 addition, which can be 1-4 addition. Okay, so 1, 2, 3, and 4. Okay, so here beta position carbocation is also stable in alpha beta unsaturated carbonyl compound. Okay, so that position may be attacked. Okay, and as well as the 1-2 position where carbonyl carbon also there. Okay, so with these two possibilities, we will be going to see the examples. Okay, so the first example, here I am taking alpha beta unsaturated carbonyl. So it just based on the alpha beta unsaturated carbonyl. Okay, so Michael addition means it is about the alpha beta unsaturated carbonyl. Okay, so if I treat with low temperature, so do the low temperature 1-2 addition takes place or 1-4? మనం ఆల్రెడీ డిస్కస్ చేసినాం 1-2 addition and 1-4. So at low temperature it will be kinetic, so it will be going to take 1-2 addition. At high temperature it will be thermodynamic. Okay, it will be 1-4 addition. Okay, so when it is 1-2 addition, the nucleophile will be going to attack on the carbonyl carbon and H will be onto oxygen. Okay, so this is 1-2 addition, 1 and 2. Okay, if it is high temperature it will be 1-4 addition, so hydrogen here and nucleophile will be here. Okay, once this is formed, this is going to result into the ketoenol transformation, so this will become double bond and here it become minus, which is supported by the plus, so hydrogen. So this is what 1-4 addition. Okay, so in the 1-4 addition, a alpha beta unsaturated carbonyl compound will be attacked at the beta position. Okay, so beta added nucleophile with saturated carbonyl which is going to form. So this becomes saturated, no? So saturated carbonyl it is going to form with beta added nucleophile. Okay, so at beta position nucleophile will be going to add. Okay, so how this becomes saturated means based on the ketoenol transformation. Okay, so it's going to give enol by the addition of 1-4 attacking. Okay, so nucleophile will attack here, so it's going to move here, it's going to move here, this become minus which is supported by the H plus. Okay, so OH and nucleophile, so this is a enol form which can be converted into ketone form by ketoenol transformation. Okay, so the cytomerism will result into the saturated carbonyl compound. Okay, so is it clear? If any doubts you can ask. Okay, so generally we have seen the carbonyl compounds so far which are with only carbonyls. Okay, once I treated with nucleophile, there will be undoubtedly attacking of the carbonyl carbon, so that it will be going to give only 1-2 addition. Okay, but the Michael addition is not such kind of simple addition. So in the Michael addition, It is majorly 1,4 addition is treated as a Michael addition. Okay. So where we are using alpha beta unsaturated carbonyl compounds. When it is alpha beta unsaturated carbonyl compounds, there will be a possibility of nucleophile addition at carbonyl carbon. Okay. So this is the one possibility at carbonyl carbon, and at the same time at beta position of the alpha beta unsaturated carbon. Okay. So this happening because once it is going to attack on the beta carbon also, then it will tautomerize, or it will be moved, this double bond will be moved towards this, and this become O minus. Okay. So nucleophile attack, and here nucleophile attack, and this is the first carbon, and this is the second carbon, and this is O minus, where it is generated by the double bond. Okay. So double bond, and this is hydrogen. Okay. So the H place which is from the nucleophile will be abstracted by this. This becomes OH. Okay. This becomes OH. So resulting into what? Enol form. Okay. So this enol can be transformed, or can be tautomerized into keto form. So this is O minus and nucleophile. Okay. Again, this H plus what is released will be attacked here. So it becomes saturated one. Okay. So far we have seen the nucleophilic addition at carbonyl carbon, which is 1,2 addition. Okay. So now 1,2 addition is not our botheration. 1,2 addition is just a simple nucleophilic addition reaction what we have seen so far. Okay. In Michael addition, we going to see the 1,4 addition. Okay. Which is happening at alpha beta unsaturated carbonyl compounds only. Okay. So when it is going to form 1,4 addition, it is generally at a high temperature. Okay. High temperature and in thermodynamical conditions. Okay. So Michael addition is the addition of the nucleophile for the alpha beta unsaturated carbonyl compounds, resulting 1,4 addition. The product will be beta nucleophile added saturated compound. Okay. Saturated carbonyl compound. Okay. సో డిఫరెన్స్ ఏంటంటే ఇక్కడ 1,4 అడిషన్ జరుగుతుంది. ఓకే. 1,4 అడిషన్ జరగడం వల్ల ఈనోల్ ఫామ్ అవుతుంది. ఈనోల్ అనేది కీటో ఫామ్కి వచ్చేసరికి సాచురేటెడ్ ఫామ్ అవుతుంది. ఓకే. సో దట్ ఈస్ ద మెయిన్ theme of this Michael addition. Okay. So we'll see one more example so that you can understand. So here I am taking acrylyl aldehyde. Okay. So in one condition I am treating with sodium cyanide and with hydrogen cyanide at 0 to 5 degrees centigrade. Okay. In another condition, sodium cyanide and HCl at 25 degrees centigrade. Okay. So at low temperature, what is going to happen? It is 1,2 addition is going to take place. Okay. So 1,2 addition means at carbonyl carbon and at oxygen. So Cn will be going to act as a nucleophile. So Cn will be going to act. So OH and Cn. Okay. If it is high temperature, Cn minus can be attacked at beta position, and double bond can be moved here, and this O minus is going to generate. So this become O minus, and here Cn, and this is the double bond which shifted. Okay. So it will abstract the H plus, so this become OH. Okay. Once enol form is formed, it's going to shift into the keto form. So make it keto form. Okay. Here I am writing directly. If it is ketoenol transformation, O minus will be generated and this C minus will be generated. That will be going to affect the proton. Okay. So this is going to be the product. Okay. So this from this product to this product is called Michael addition. Michael addition is the addition of alpha beta unsaturated carbonyl compound. Okay. So generally in Michael addition there are two types of the products. Okay, types of the reacting molecules. Okay, so one is Michael donor and another one is Michael acceptor. Okay, Michael donor and Michael acceptor. Michael acceptors are nothing but so far what you have seen alpha beta unsaturated carbonyl compounds. Okay, alpha beta unsaturated carbonyl compound. So one, if it is nucleophile, it is going to attack or it is going to give the electron density to the compound. Okay, so this is accepting the electron density or this is accepting the nucleophile. So they are said to be Michael acceptors. So all alpha beta unsaturated carbonyl compounds. Okay, and all alpha beta unsaturated carbonyl sorry uh, carbonyl compounds, aldehydes and ketones, okay, and all alpha beta unsaturated esters, okay, acid derivatives also, okay, and so acid derivatives can be esters, can be amide, okay, can be even acids, okay. So these all can act as a Michael acceptors, okay. So to become Michael acceptor, okay, to act as a Michael acceptor, it must have alpha beta unsaturated carbonyl group, okay. So what is common in this, okay, this group. If it is there, it can act as a Michael acceptor, okay. Then what could be the donor? Donors will be nucleophiles, okay. So for example, if I take nitromethane, okay, nitromethane. So this is acidic proton. After removal of H plus, it becomes a nucleophile. So this can attack on the carbonyl, okay, to result Michael addition, okay. So active methylene groups which are acidic, okay, these can also attack and this can also be acts as a donor, okay. So what are the active methylene groups? Active methylene groups are the methylene which is with two withdrawing groups attached, okay, strong withdrawing groups attached, okay. So you can take the aldehyde here, you can take the ester here, you can take the anhydrides, you can take the cyanides, you can take the nitro groups, okay. So whatever may be the withdrawing groups, if it is having two sides of the methylene, then they are said to be active methylene, okay. So not only that, there are many other. For example, organometallic, grignal, okay, grignal. So that can also be a nucleophile. So lithium, organolithium, this can also be nucleophile. So these all nucleophiles can be considered as a Michael donor and all alpha beta unsaturated carbonyl systems. Okay, not just carbonyl compounds. Here I am saying carbonyl system means C double bond O and with this double bond. These all can act as a Michael acceptors. Okay. So when the combination of a Michael donor and Michael acceptor, there will be a Michael addition. Okay. So that is the logic. You need to identify the Michael acceptor. You need to identify the Michael donor so that a attacking of 1,4 addition. Okay, 1,4 attacking should be taken place to resulting into the Michael reaction. Okay. So whenever these two combinations are there, you must go for 1,4 addition instead of 1,2 addition. Okay. So that is the logic. So let's begin some of the examples. So Here I am taking a compound and treated with nitrometer. Okay, so CH2 and water minus. Okay, so in Michael reaction, if it is alpha beta unsaturated compound, it acts as a Michael donor. Okay, and it will be, sorry, this is a Michael acceptor, this will be Michael donor. So it's going to attack here and double bond will shift here. Okay, so that product will be O minus and double bond, and here CH2 NO. Okay, so this is supplied with the H plus. What if I am taking methyl nitrate, okay, nitromethane. So this is acidic proton. So this releases H plus and it becomes CS2 minus. That is going to attack here. Once it is attacked, H plus of this in this system will be attacked by the oxide ion, resulting into the enol of the product. So while writing the products of the Michael, you must take care the number of carbons. Okay. So here it was a carbon. So count the carbons. Okay. 1, 2, 3. Okay. So and this is 4. This is 4. Okay. So if you just adding here itself nitro group, there will be one carbon less. Okay. So be careful. So once it is enol form, that will be converted into ketone. Okay. So this is the product. So now try to write the products for different compounds. Okay, so as a workout, so this reagent and these two active methylene reagents, how they are going to generate this? If I take simple active methylene compound and in presence of any OH or any base, triethylamine or any base, if I treat, so they are going to give this anion. Okay, or soda-amide, NaNH2, sodium ethoxide. Okay, whatever may be the base is going to result this. Okay, so there can be that kind of reagent system also. Okay, next. One more question. So if the product is this one, uh, what could be the starting material? I'm just using this. Okay. So here combination of X and Y, Michael acceptor and donor resulted into this product. So what are Michael acceptor and Michael donors for preparation of this compound? Okay, and similar type question. Base Yes. So this is about the Michael addition. So in the next class we will be going to see the 1-2 addition management and 1-4 addition management. Okay, with the use of metals. Okay, for example copper and lithium based Gilman's reagents. Okay, so how they going to define or direct the 1-4 addition and 1-2 addition. Okay, try to solve these questions. Okay, so Michael addition is one of the important. You need to look into these examples more carefully. Okay, and try to practice more examples. Okay, so you must get doubts based on the 1-2 addition and 1-4 addition. So if you get any doubts, I'm happy for that. So please post in the group so that we can discuss what could be the addition strategy with the different reagents. Okay, so try to solve and try to post more doubts or more questions about this. Okay, thank you.